Okay, here's your overview of the C4 topic, lesson 13, electrolysis of aqueous solutions. So first of all, what's an aqueous solution? This is where we have a substance dissolved into some water. So how does that happen? Well, water molecules are what we call polar. It means that they have a slightly negative end to them and a slightly positive end to them. And because of this, when we place something like salt, table salt, sodium chloride, which has a giant ionic lattice structure, place that into water, the water molecules pull away the positive and negative ions. And as a result then, they do this because they've got their positive ends and negative ends, just like we've shown here. And when we see this inside a container, we'll see that all of the positive water molecules are surrounded by the negative parts of a water molecule, and all the negative ions over here are surrounded by the positive side of the water molecules. So it pulls apart, breaks apart, and dissolves an ionic compound made of positive and negative ions. This is dissolving. At the same time, we also have water molecules that dissociate. We mean that they split up. They're going to form hydrogen ions and hydroxide ions, and these can also revert back into water molecules. So quite a lot going on there in just some salt water. So we can use this now to do electrolysis. So if we take some sodium chloride solution, which is just salt water, inside our salt water, we've got sodium ions, hydroxide, hydrogen ions, we've got chloride ions and hydroxide ions. As soon as we put the electrodes in and turn on the switch, both the sodium and the hydrogen ions will be attracted to the negative cathode. However, only one of them is going to react, and it's always the least reactive of the two. So in this case, hydrogen is less reactive than sodium, so it will react, produce hydrogen atoms, which then form H2, hydrogen gas, and we'd see bubbles of gas here. And we can test this by doing the squeaky pop. So at the cathode, we always choose the least reactive. The sodium is left in solution. Over at the anode, we've got chloride and hydroxide ions. We always choose the halide. So the chloride ions are converted into chlorine atoms, which then combine to form chlorine molecules, and we get chlorine gas being produced. And we can use litmus paper to test if it is chlorine gas. The hydroxide ions are left in the solution, and therefore the sodium and the hydroxide ions that are left behind helps us form sodium hydroxide solution as our third product. So we have hydrogen as one product, chlorine gas as another product, and sodium hydroxide solution. There are half equations for these reactions as well. So at the anode, we've got our two chloride ions, which lose 2 electrons, one each, and then form a chlorine molecule, Cl2. And then at the cathode, we've got 2 hydrogen ions that gain an electron each, and as a result turn into hydrogen atoms, which then pair up to form hydrogen gas. And that's your overview of the C4 lesson 13, electrolysis of aqueous solutions.